we have an elastic collision. An elastic collision is one in which kinetic energy is conserved for the entire system before the collision and after the collision. So if you add up the kinetic energy of, if you calculate the kinetic energy of cart A and the kinetic energy of cart B before they collide, whatever that number is in joules will be the same total number after the collision. That's what it means to have an elastic collision. Momentum is always conserved, and so the total momentum before the collision is equal to the total momentum after the collision. That's true for an inelastic collision and for an elastic collision. But we get to solve for one extra variable here because it's elastic, and we can consider kinetic energy to also be conserved. So I have two cars coming towards each other. Cart A has an initial velocity of 30 centimeters per second, and B is going in the opposite direction to the left at 10 centimeters per second. That's why the negative sign is in there. And the mass of A is 75 grams, and the mass of B is 125 grams. I intentionally kept them in grams and centimeters to make the point that you don't have to convert as long as you're not calculating something in joules, because a joule would have to be a kilogram meter second. You'd have to convert. And we're not calculating momentum in kilogram meters per second. We just are looking for the final velocities of the two objects, and I'm going to leave it in centimeters per second. As long as all your units are consistent and you're not calculating something in joules nor newtons, we'll be fine. So I'm going to start over here. For an elastic collision, only for an elastic collision, the sum of the initial and final velocity of cart A adds up to the same number as the initial velocity of cart B plus its final velocity. Again, that is only true for an elastic collision. It doesn't matter that the masses are different. That's true, and that's where you start. So that's 30 plus VA, that's the final velocity or velocity of cart A after the collision, which is one of the variables we're looking for. That equals negative 10 plus VB. And now we are going to solve for VB. You can solve for VA or VB, it doesn't matter. I'm going to solve for VB by adding 10 to the other side, and I'm just going to switch them. So VB equals what? 40 centimeters per second plus VA, right? Add that to the other side plus VA. There we go. So now we have an expression relating the velocity of object B after the collision to object A. And then the easiest way to do this is to go into the, I'm going to go into the other board and solve using conservation of momentum. All right. Okay, continuing on, I rewrote these for you right here. So that we just figured out that VB is 40 centimeters per second plus VA. And here are all the variables. We're looking for the final velocities of A and B after the elastic collision. All right. So the easiest way to solve it is to solve it using momentum conservation. The total momentum before the collision equals the total momentum after the collision. Total momentum is equal to the sum of that of A plus that of B before and after. Remember, this is the mass of A times its initial velocity plus the mass of B times its initial velocity, mass of A times its final velocity plus the mass of B times its final velocity. 75 times 30 plus 125 times negative 10 equals 70 times VA plus 125 for VB times, well, we just figured out this VB is 40 plus VA. 40 plus VA. Now it's a fairly simple problem. We only have one unknown variable, VA, and we solve for that. And I've already done some of the math here. This is 2,250. That's going to be minus 1,250 equals, well, 75 VA plus 125 VA is 200 VA. And then 125 times 40 is 5,000. So now, 2250 minus 1250 is 1,000. Plus 5,000. Subtract that to the other side, solve for VA. You get negative 4,000 all over 200. So what's that? Negative 20 centimeters per second. So in other words, after the collision, cart A goes backwards, because remember, its initial velocity was positive 30. After the collision, it's going in the opposite direction at 20 centimeters per second. To find the velocity of B, well, we already know that B equals 40 plus VA. So that's 40 plus a negative 20, which comes out to be a positive 20 centimeters per second. And so for cart B, before the collision, it was traveling in the negative direction at 10 meters per second, so that's negative 10, and then afterwards it has a positive velocity of 20 centimeters per second. Again, the beauty of an elastic collision problem is that you can solve for two variables. We didn't know either of these variables, and we were able to solve for both of those.